So just by way of introduction for those attending, and I see we have quite a few coming in now. My name is Graham Lee. I'm the head of research at TDi Sustainability. For those of you who don't know TDi very well, we are a consultancy company that focuses on responsible sourcing and on helping businesses to unlock sustainability, as we say in the catchphrase, to work with businesses around the world in order to help them to reach their sustainability goals, particularly around the sourcing of materials and material supply chains, engaging with those supply chains in order to mitigate risks and maximize the positive outcomes for people and planet. We've been partnering with a team of students from the Duke University Nicholas School of the Environment. I hope I got the name exactly right. Excellent. Nicholas School of the Environment to look at some of the sustainability considerations around the sourcing of bioplastics. Bioplastics being a very new upcoming resource about which there's a lot of buzz around sustainability, and as part of the students team's master's work, they have each team partners with an organization that's actually in the commercial sector, and works on a research project. We have had 4 team members in our research team over the past many months, looking at these considerations around bioplastics and sustainable sourcing. After much effort, their research is coming to a close and their course is coming to a close. And so we've organized a webinar, and Patrice, who's speaking on behalf of the student team, has kindly agreed to talk through some of the findings of their research with us. So over to you, Patrice, to say a few words of introduction, please. And then I will ask you some questions.
Well, that was perfect. You got the school right, what we're doing. So as Graham mentioned, I'm in a student group of 4 of us, and we've been working really hard this last year to kind of understand the bio-based plastic market and what drivers on how you can scale it sustainably. Last week, we just had our master's presentation. It was a symposium where we talked through those findings that we wrote up in our report. And it's been just a really good experience. So I feel really lucky that my team decided that we could talk here about our findings.
Great. So I am going to quiz you a little bit about your findings. We're going to kind of run through some questions. I'm going to ask you all about what bioplastics are, what you learned about them, what recommendations you have for a more sustainable future for the bioplastics supply chain. And there's going to be time at the end for attendees to ask us questions as well. But if you have a burning question in the middle, then I think we can be flexible enough to accommodate that. So please just make yourself known. I think we have a hand-raising facility for attendees. If not, Agnes, please let me know and we can think of an alternative. But yeah, just let us know if you have a question, pop it in the chat, and we will endeavor to answer it on the fly. All right, Patrice, so start us off, please. What are bio-based plastics?
So the term bio-based plastics encompasses a lot. And what I like to do, what our group has decided to do when we talk about it, we kind of like to do a little level setting just to make sure everyone's on the same page with the terminology. So bio-based plastic usually refers to plastic that's made from some sort of biomaterial or biomass. When you're thinking through how it's different from traditional plastics usually come from a fossil fuel and go through like a chemical production phase to create plastic pellets that are used in a product creation which are your typical plastic water bottles, plastic containers, and so forth. Whereas bio-based plastics really focus on using like raw materials from agricultural goods. So you can think of that with like corn, sugarcane. There's also the potential to use waste-based. So it could be like waste cooking oil. And then that goes through a pre-production process of either biological or chemical fermentation, and it turns it into bio-based plastic pellets. And then that is used in the product creation phase. So in bio-based plastics, they're usually visually similar to traditional plastics, but they vary in the technical capabilities. But most bio-based plastics you'll see are plastic water bottles, plastic containers, plastic utensils. And the key aspect for bio-based plastics, the selling point that everyone loves to talk about, is their end of life, where their end of life allows them to be compostable, allows them to be recycled, not all of them, but most. And then usually when people talk about bio-based plastics, they're thinking of the traditional PLA, which is a type of bio-based plastic, or PHA, which is another type. And the main difference between these two is just that like chemical processing, that pre-production I was talking about. And that chemical processing changes up the end of life of the type of plastic, the type of bio-based plastic. And then most of these plastics you'll find in like the food service industry as a single use. Most bioplastics aren't really durable goods, but you'll usually find them, as I mentioned, in like a single use capacity.
Understood. Okay. And so what was your research focused on? What was the kind of central research question that you were looking at with bio-based plastics?
Now, so when we started this off, the big question that TDi came to us with, was this question of, is there a market for waste-based bioplastics? Waste-based bio-based plastics, terminology here. And when we were diving into that, that's when we were looking to see in that like value chain, that feedstock, could it be made from waste feedstock? And in this research that we did, we ended up finding and changing along the way to look instead of just at waste bio-based plastic, but looking more at the market in total and what was available of just bio-based plastic. So one thing that I really like to talk about and that I found really interesting was, if we just look at like some numbers, so single-use plastic, I think it's about 300 million tons plastic waste produced yearly, and about half of that, so about 300 million tons of plastic waste produced yearly, and then about half of that is single use. And there's such a low recyclability rate of single-use plastic that this idea of diving into bio-based plastics, which could increase this recyclability, this compostability, this sustainability, is a really hot button topic. So when we were looking at waste-based bioplastics, we knew that there wasn't as big of a market as we thought available there. So that's why we transitioned to looking more at bio-based plastics in total. And as I mentioned, like the recyclability rate, it's really between like 5 to 6% of traditional plastics. So this is just a really emerging market, and that has been growing. That has been a good source to dive into, and it's been really interesting to see some of the conversations that have been happening in that space.
Yeah, great. Okay. And I mean, your research focus was essentially about the sustainability, the potential of bioplastics, wasn't it? And like what we really mean by sustainability when we talk about bioplastics. What is a sustainable bioplastics supply chain? What does it look like, and how can it become a reality? And I mean, why is this such an important topic of research? And what was your approach to trying to find some answers to those questions?
Yeah. To your point, it's so important because of like that number, right? The 300 million tons of plastic waste produced yearly. you've heard those stories, right? About in the Pacific Ocean, there's like the plastic island, right? Or there's a hot button topic of like save the sea turtles by no more plastic straws.
Yeah.
So it's been really in the consumer's mind of really reducing our consumption and use of traditional plastic products. And we thought it was like really important to do this work of figuring out, we hear this term bio-based plastic, we see materials that are available, but why hasn't it become more mainstream? Why don't we see larger consumer packaging good companies producing bio-based products? Like when you walk into the store and you're trying to buy a 2-liter soda bottle, right? Why aren't you automatically thinking, yes, this is a bio-based plastic, right? Those ideas of it's not as prevalent in our everyday lives is why we really thought this was important. And we really wanted to just understand how like producers, the ones who are creating these bio-based plastic pellets, how they are thinking and defining bio-based plastics. And then your buyers, your large consumer packaged goods companies that are creating products and like that product creation phase, like why they either are buying it maybe in a smaller quantity or not, and they're not creating products. We wanted to understand that relationship between it. And then we also were just super curious about why so much plastic ends up in the landfill. Like, is that something that can be mitigated with bio-based plastics?
Yeah, yeah. Okay. So, I mean, that's the considerations of what's going out. What's going in? What are people making bioplastics out of?
Yes. So when you're thinking about bioplastics, most bioplastics are made from, as I mentioned, like a raw material that is a biomass of some sort. So you have different generations of feedstock, is what we call it. And in our research, we saw that in the market, it's broken up into 3 different large buckets. You have your first generation feedstock, second generation feedstock, and then third generation. And in your first generation feedstock, that is like your typical cornstarch or sugarcane. It's usually that raw material that you would get from an agricultural source that's like grown on a farm, right? And that it's the most prevalent that you'll notice. I mentioned briefly at the beginning, like PLA, that's a type of plastic. Most of that is made from first generation. First generation also tends to be cheaper than the others, and it's more available. And then you have your second generation feedstock. That is your typical waste materials. So you could use waste cooking oil, corn stover, which is a byproduct of like the corn product. So you can use that in making a different type of plastic, a different type of bio-based plastic. And then that is usually a little more expensive, and availability starts to go down. And then you have your third generation, which we like to call more of the novel. So this is where I would say researchers truly are pushing the boundaries of what can become a bio-based plastic. So in that case, we've seen studies about like algae and different types of seaweed being used to create bio-based plastics. And unfortunately, as you can guess, or as you can probably guess, that is more expensive, and the availability of the product is really, really small. So when you're looking at what goes into it, you're really trying to figure out and trying to blend how much do you want to spend for it versus how available is the product and is it scalable? And then like what are the individual components that are stopping you from hitting any of your like company targets, depending on if you're a producer or buyer.
Yeah, yeah. And so you've started touching on some of the obstacles there. Let's explore that a little bit more. I mean, what are the big issues that are stopping bioplastics from being everywhere in the shops? Like you say, what's blocking this from kind of taking off in a big way right now?
Yeah. So one of the big things that are blocking it, it's this thought of like food and plastic competition. So as I
Uh-huh.
mentioned at this beginning part, first generation plastics are typically made from a raw material that's like an agricultural resource. And that has people worried that there is a competition there's food competition there. Then there's there's like a lack of scale also when it comes to bio-based plastics. So because it requires a lot of land to be made in like first generation, then you have like that constraint, right? Second generation with waste-based products, you have the constraint of only as much as the raw material is produced, you can use as like a waste, right? And then it's kind of more expensive. So that's another component is the expense compared to traditional plastics is a lot higher. And then there's confusing terminology. So I'm sure everyone that's listening has heard us bounce between the terms like bioplastic or bio-based plastic, right? They have different connotations and different definitions. Although consumers, when you're walking into a store, you're not looking to buy a product and stand there for 10 minutes Googling, what does this mean? What does this mean, right? If it's on the packaging. So there's really confusing terminology in this space that I think prevents companies from seeing value in investing in a product if a consumer doesn't understand that value. And then like the end of life, right? So we talked briefly that we thought that was really important to research. And one concern with like end of life is if bio-based plastics aren't recycled or composted correctly, then they can be sent to a landfill. And if they decompose there, it's like in a aerobic environment, and that can lead to like methane emissions. And then you can also have potential contaminants in the recycling system if you send bio-based plastics to traditional recycling systems. So it's like all of those aspects combined kind of keep bioplastics from scaling as much as we think they would.
Yeah, great. And I mean, those all sound like quite kind of technical engineering challenges or like consumer relations challenges, except for this thing about competition with food. So, so how how are we going to overcome as a society? How are we going to overcome this issue with the competition between bioplastics and also biofuels in the mix there and food production?
Yeah. So unfortunately, we don't have an answer per se. We're not an expert here, right? In our research, we thought that we would find an answer to this, right? So when we done this project, we decided to do not only like academic research of what is in the literature, right? But we also thought that it would be really prevalent to talk to producers and buyers. So we had these different stakeholder conversations with NGOs, certification organizations, producers that are, as I mentioned at the beginning, like producing like these bio-based plastic pellets, and then also buyers of these products who would be turning it into the product that a consumer would buy. And in all of these conversations, that was one of the interview questions you would ask was, what is like, how do you get over this food or conversation? And we saw two ends of the spectrum. We saw some of the people that we talked to, they used a common refrain of, it's not food or bioplastics, it's food and. And the reason why they talked about that was like bio-based plastics, they take up, the production is like 0.02% of like the global arable land is used for this. And it's only expected to grow to like 0.6% in 2027. So in that case, you're thinking of it as you're not taking a huge portion to scale bio-based plastics, and it's not a competition. It can be used together there. Then on the other side of things, you have people talking about how, like, although it may seem like it's a small land use, this also begs the question of like, how do you compete with like, how do you price the land and competing with other agricultural products for different communities who would potentially be using that land to create a different agricultural product to eat instead of an agricultural product that would be used for this. And there was a statistic that we saw that said that bio-based plastics would require 54% of the world's total 2019 corn production to truly be scalable. And like, that's huge, right? So in these conversations, it was two sides of the spectrum of there's a potential to make it better. There's a potential that it's not feasible. And again, that comes back to this confusion, right? What is the answer? And one of the recommendations that we came to after having these conversations was that, going back to like the feedstock table, the potential of using waste-based feedstock or investing in that market is a viable option, because instead of traditional agricultural land being used just for bio-based plastics, waste-based feedstocks could use like the waste of food-based corn. It could use like that waste and create a bio-based plastic, or waste cooking oil, right? Like you can use waste products in that food stream to create these products instead of competing with land. There's also like the thought of using degraded lands. So using degraded land and farming these agricultural feedstocks to help reduce that food competition argument, because the land wouldn't have been used for food anyway. Now you're rejuvenating it by introducing these bio-based, these raw materials that would be used in a bio-based plastic.
Right, I see. Yeah, that's a really interesting kind of middle ground with the underused or degraded land. Yeah, yeah, great. And I mean, with the waste-based bioplastics, I mean, again, we get to this question of sustainability, scalability, don't we? Is there enough cooking oil and and sugar, kernel and palm kernels and and sugar bagasse out there in order to make significant amounts of bioplastics? And I mean, what were your findings in that area?
Yeah, I think for that specifically, it comes to the end of life. And I think really being able to make a case for waste-based plastics. Yes, it talks about it. It hits this idea of like food and food production and bio-based plastic production, right? Or biofuels as well. But another really big proponent for it is this end-of-life conversation. So on the type of chemical or biological process that happens to the raw material, where these products end up, whether that's a landfill, whether it's compostable, whether it's recyclable, that is important to understanding what type of feedstock you should use. So as we mentioned, like when we started and we were talking with producers and buyers, we had started this conversation as really just looking at that part of the system of the value chain of saying, what do producers want, what buyers want, what products are being created. But it was after those conversations that we realized this end of life conversation really dictates what type of product can be used or what type of feedstock should be used in the creation. So with waste-based products, right, or waste-based feedstocks, most of those end up being compostable, and that can be either like home composted. So if you have like a backyard and you have, you're doing this yourself, or it can be industrially composted, which gets sent to like an industrial facility and it gets composted there. And it also can be recycled. So if that is the case, to say we can do these, like these are the aspects of this product, then it makes a stronger case for waste-based bioproducts, because you can now say, well, we know that we want to reduce landfill waste. We want to increase our company's sustainability. And to do so, we can make the valuable case, the cost case for spending a little bit more on these waste-based feed streams. But as we mentioned, we weren't able to focus our research fully on that just because the market is so nascent. And I think people are having these conversations and are starting to find this and are starting to dive in that direction. I can say for some of the interviews that we did, that was some of the conversation we had of, well, there could be a potential for this. if we move past, like after we get past this research phase and we've kind of parsed out which feedstocks would be the best and what processes would be the best. So I do think it is a potential viable option in the future. It's just trying to iron out all of these nicks and then like doing further research. I'd be super interested to see how this market grows as we move forward.
Yeah, yeah, absolutely. And that's something that I was really interested in from your research, is really drawing those links between start of life and end of life. It's not really a case of all plastics being equal or all feedstocks being equal. It matters for the entire system what you put in at the start. Um, that brings me to the end of all my questions. I can see we got 4 questions from the audience here. For those of you who wish to ask questions but haven't figured it out yet, there's a question and answer button you should be able to see. And you just open that up and type a question, and we will go through these in order and get to yours next. So the first question I can see here is, what happens if you send a bioplastic item to a traditional plastic recycling plant?
Ooh, okay. So this gets a little into the technical details, but from what we saw, and I mentioned this briefly, like this contamination aspect, the reason why bio-based plastics can contaminate a recycling facilities plant is the way that they decompose. So although bio-based plastics are visually similar to traditional plastics, their technical elements, like some of their thermal properties, may vary. So if you're at the farmer's market and you get a plastic container and you're told that it is a PLA container, that plastic container may be, one, a little bit thinner in a plastic, and two, you keep it out in the sun, or if you put it next to your stove, it may, and that is just purely based off of like the chemical properties of that plastic. But if you take that compared to a traditional plastic container and put it next to a stove or leave it out in hot conditions, it'll like hold its integrity. So when you're sending it to a recycling plant and you're sending it to be either mechanically or chemically recycled, depending on the processes there, that those technical aspects of the containers or of the bottles, whatever the material, make it more difficult to recycle than your traditional plastic containers. And then something we also saw that was really interesting was with recycling plants, there's a lot more manual separation than you would expect. So you would send like these large bundles of plastic there. And the way that it gets sorted and recycled, it's like through weight distribution, through cleaning, through manual moving containers and bottles aside. Like it's all those processes, and adding that extra element of the chemical and the chemical properties of a bio-based plastic make it difficult to recycle in the same way.
Yeah, okay. Do you think consumers or producers have more power to promote bio-based plastics, and how can we encourage it?
Ooh. We would say we think consumers have a lot of power here. And this comes to the question of how do you educate your consumers to understand what they're asking for? Because I think there's been a push for bio-based plastics. One of the literature reviews that we looked at did like a study, and they were asking in different countries people's experiences on like, how do you define a bio-based plastic? What type of bio-based plastics do you buy? And then a really interesting question they asked was, would you purchase bio-based products if they were available? And there was like an overwhelming percentage that was talking through, yes, they would spend a little bit more to purchase it. But because terminology varies, so you have terminology like compostable, which doesn't necessarily mean home compostable or industrial compostable. You have biodegradability, which depending on where you at means a different thing. Like a bioplastic could mean that it's not fully bio-based, and it could have some traditional plastic elements in it, like virgin plastic mixed with a biomaterial, and that's a bioplastic. Or you could hear something say bio-based. So all of those terminologies make consumers asking for something, make it difficult. So one of the recommendations that we made in our report was like really educating consumers on terminology around bio-based plastics. And then like on the producer side, there's that could be filled with investments and partnerships with like key stakeholders, because this idea of being able to not only educate, but being able to like certify where a feedstock is coming from, like is it fully bio-based, involves like a communication and a partnership there that we think is a potential solution. So it's not one or the other. It's more, what makes this complicated is it's a mixture of people doing different bits and pieces that really will drive this market forward.
Yeah, understood. So our next question is what volume of bio-based products need to be available in order to compete monetarily with more traditional plastics, and when will that volume become available? And I suppose more generally, there's a question there about at what point, where's this threshold going to be reached where this whole kind of industry becomes really commercially viable, and how soon are we going to get there?
So that's really interesting as well. And one of the technical things that we saw was going back to how a bio-based product is produced. The reason why it's so expensive is that, or let me back up a sec. So traditional plastic, when it's produced, it's able to be produced at a really cheap price, right? So then the product creation of it is financially viable. But for a bio-based plastic, when you take the raw materials and you turn it into those bio-based plastic pellets, that conversion factor isn't a 1-to-1. So traditionally, it's like a 1 to maybe 0.5, if that high, 0.6. And unfortunately, that then means that you're having to buy a lot more of this raw material to create a small amount of your bio-based plastic. And that also, like, that process makes it really expensive. So when you look at like the technical process of creating a bio-based plastic, there are these different aspects that could be improved, like processes that could be improved that would overall make and reduce the cost price. One of the conversations we had with the producer talked about how they felt like there was an ability for them with their startup, and they talked about like the technical aspect and of the production of bio-based plastics, that they think that they could bring down the price cost by at least half with just their new ability. And it's like those aspects building up together in the process would make it more cost competitive. In terms of like volume, that's hard to say because it really depends on, are we looking to produce like product lines from it? Are you looking to like completely replace traditional plastics? An example we like to give was we saw Coca-Cola, they had something called a plant-based bottle that they advertised, and it was like popular for a while, and a plant-based bottle, but it wasn't fully bio-based, purely because of the technical components we mentioned of it being able to hold up. So it was more, it had virgin material mixed with bio-based material. So it's that question of like, are we looking to do that? Are we looking to blend the two together? If you're looking to completely replace, that's a whole other question. So I don't think there's, at least we didn't find a specific answer for what would be the volume per se, but it's really optimizing those processes on each step of the bio-based plastic creation that would reduce the price, that would make it feasible to scale and bring to market.
Yes, I see. Yeah. Okay, so we watch this space.
Yeah.
I'm going to summarize the next question now. It's a little bit of a long question, but I think it's a yes, an interesting question. What about countries, in particular developing countries, that have banned single-use plastics? Because as the question answer says, the problem with banning single-use plastics is where does all of the alternative virgin material come from? So do you think that bioplastics could help alleviate some of this supply crunch, given the constraints in scaling bioplastics? And what's the feasibility of a solution here?
Yeah, that's interesting. And this also makes this makes the market even more interesting because we focused a lot of this research really on the US because it was what was available with the time constraint, like the scope of the project. So we didn't spend a lot of time looking internationally per se. But one thing that we did talk about as a group was with countries that are banning single-use plastic, the idea of a like fully bio-based plastic presents a possible alternative. Now, going back to the technical aspects, you don't have a one-for-one trade-off just because bio-based plastics aren't really used in durable goods. Again, going back to like that thermal, it might look the same, but it doesn't physically act the same. So there is an argument to be made that it could be used as an alternative, but at the same time, it needs development in the technical aspect to truly replace what we're used to in the plastics market. An example we can also give in a conversation we had, we were talking with an airline company about why they don't use bio-based plastics when when you go and you order a drink, right? It's in a plastic container. Like, why don't you use plastic there? And the conversation, the answer there was that because they travel internationally, they have to abide by different regulations based off where they travel. So using and developing a bio-based plastic may not be feasible in some options because, as we mentioned, it may not be fully bio, like it may not be a full product just from biomaterials. It may be a mixture with traditional fossil fuels, and that may be fun. So it's trying to navigate the different regulations that really make it hard. And one of the recommendations we did make was like standardizing labeling. So this standardizing labeling nationally, but ideally internationally, if you are a large company, right? So that when you're anywhere in the world, you understand what you're buying, you understand the components in it, and you know that it will meet those guidelines and regulations from different areas. I don't know if that fully answers the question, but I hope that gives like some clarity into the potential there for bio-based plastics replacing single-use plastic.
Yeah, I mean, I think that certainly points us in some really interesting directions in terms of, how to set the conditions so that that market can grow. Next question is not specifically on bioplastics. I think it's more of a general plastics question. So perhaps not quite your subject matter expertise, but let's see. How is the separation of plastics being planned on a large scale to increase the accessibility of recycling?
So one thing we saw, and it's not necessary, so recycling traditional plastics and recycling bio-based plastics that we mentioned are different. But what we did see in looking at this was the end-of-life capabilities that are available for traditional or bio-based plastics are lacking. So as it stands, like we gave the percentage at the beginning, I think like 5 to 6% of plastic is really being recycled, which is not a great number when you think of all the work consumers try and do to separate it out, right? Or when you see the recycling bin and you put your plastics in there. And the main reason for that is because if you have food contaminants on a plastic container, that's really hard for the recycling companies to clean off and then to end up recycling. So it decreases the value for them and they no longer want to use it. And just because it's like such low margins, they have to go through so much product, they don't put in the effort per se to do that extra because it doesn't add value to the end product. So when we think about like that end of life for traditional plastics, it would really be helpful to be investing in some of these larger scale manufacturing companies or larger scale recycling facilities or composting facilities, well, more recycling facilities for traditional plastics, because you would want there to be a increased activity in this market to increase the want to recycle from these larger scale recycling plants and companies. And then I guess on the bio-based plastic side, in a similar sense, we really thought that increasing composting, industrial composting facilities would be helpful because of that same aspect. Like you want to increase the access to the end of life. So you're not just making the claim and saying, oh, the product can be recycled or can be composted. You want to make sure it actually ends up that way.
Yes, yes. No point in making a recyclable product if no one actually recycles it.
Yes, exactly.
Yeah. Last question, I think. Do bio-based plastics break down fully if they end up in the ocean, or can they still be a threat to wildlife?
Interesting. Yes. So this goes back to the comment on you want to make sure they're recycled or composted in the correct way. So the PLA we talked about, if PLA is sent to, so PLA, it's described as being industrially compostable, right? But if you send that to a landfill and it's just sitting in a landfill, after a certain amount of time, it may decompose, but the way and in the environment that it's decomposing, it is not what we would consider sustainable, right? It might be producing methane, yes, whatnot, right? So in that similar aspect, now, I don't know if we looked at any specific studies on like what salt water would do to decomposition per se, but in the similar vein, you wouldn't want those products to end up in a oceanic environment, just as it would be like a disruption to the wildlife that would be there. Even if let's say it takes like 12 weeks or 12 days, whatever, to decompose, you're still having an environmental impact during that time period. Now, there are other plastics, when you talk about like PHA, that advertises itself as being more like home compostable. And that idea is that if you're putting it in the proper home environment, then it will decompose fully and it will be safe for that environment. But it's the still same aspects. Like it's the tested scenarios that make it decomposable, but make it decompose or make it compostable. And whether or not it's sent to like an ocean, that's not somewhere we would want our plastics to be, even if it's a bio-based plastic.
Yeah, I think I think that's it, really, isn't it? I mean, that's the crux of it. You wouldn't want them in the ocean in the first place, even if they biodegraded. There's that period of time while they're biodegrading, and then also even once they're biodegraded, they don't just disappear, they've turned into other chemicals. And I don't know if you're aware, I'm not, but I don't know if you're aware of any studies of, what those chemicals are going to do in the marine environment. But certainly any sort of uncontrolled release of those industrial chemicals carries the potential for harm to marine animals.
I'd be super interested to see to see a study done or an expansion of even this project in the marine environment. And again, when we talked about like just the scope of the project, we really focused on like the US boundaries here, and more of like landfill compostable opportunities and challenges. Would be really interesting to dive into of what is available and what research is there on decomposition in a marine environment.
Okay, well, there you go. So you and the rest of the team can all start internships at TDi and spend the next year researching.
Hey, we're all we're all graduating, so we're all here headed out into the real world. Hopefully to be making an impact in the same way that we tried to make an impact with our master's project. But the next group that's coming up the second year is TDi. You all can come back for another master's project.
There you go. All right, Patrice, thanks very much for your time. To anyone who missed the very start of the webinar, Patrice and her student colleagues at Duke University have been in a research partnership with TDi, looking at some of the sustainability considerations around bioplastics. This has been part of their master's project. Patrice was kind enough to talk us through some of her findings. So thank you for that, and best of luck to you and the rest of your team with your exams and with those next steps after the course.
We're almost there. It's graduation's right around the corner. But thank you so much for having me. It was great talking about this. As you can see, it's a big market, and there's a lot to talk about, a lot of different directions to go. So I appreciate the questions, even from the audience, trying to parse it out. Thanks, Graham, for having me.
We got one more question. Do you have time for it?
Sure.
Does the location matter when trying to recycle or compost, as you might say? For example, is there a difference that should be considered on the East Coast versus West Coast versus overseas?
Yes, so that comes back down to like the facilities that are available. So when we're thinking nationally about composting facilities, those are more available regionally. And it's really just the conversation of, is it worth the trip? Like, is it cost competitive for those facilities to put out the resources to get these products in those locations? And sometimes it's not, just because it's too far to fully to send it to a composting facility. Sometimes the local collection and the separation of the product, it's not valuable to, there may not be enough of the bio-based materials or bioplastics to actually separate them out and send them to a recycling facility and like pay that additional cost. So like overseas, East Coast, West Coast, all of those considerations come in when you're looking at the market and looking at it from a price, looking at it through the lens of price, because it may not be price competitive. And again, that comes right back down to why the recyclability rate is so small. That's because the market is not profitable enough for a company to put in the effort to send it to a composting facility or a recycling facility when they're not nationally located and they're so small. They're only small facilities located in like regional.
Yeah, and that brings us on to another really interesting question as well, which is, how do those economics change when you move out of the States, when you move out of Western Europe, and into countries where the cost of labor is a lot lower, whereas other costs are a lot lower, and you can actually look at much more low-tech solutions for recycling collection, recycling sorting, and things that wouldn't work in the West, can actually work really well in those developing economies, and those developing economies can be leaders in these sorts of innovations, simply because the economics look slightly different.
True.
Yeah. Anyway, I'm glad we were able to squeeze in that last question. So I need to now say goodbye all over again. Thank you very much, Patrice, for your time, and all the best for the future.
Thank you so much. And thank you everyone for jumping on and having this conversation about bio-based plastic.
Thanks, everyone.